Okay, 9.7, exponential growth. So exponential growth increases at a steady rate over time, but what you'll notice is that well, you'll see it here in a minute. So the general equation for exponential growth is y, the total, is equal to a, which is the initial amount, times the quantity of 1 plus r, where r is your rate. So whatever your rate is, plus the original. And then t is time in years. So if it says months, like in 3 months, you have to remember to use a fraction here and not years. So number one, Altobelli City had a population of 25,000 people. If the growth rate is 3.2%, we're going to write the equation to represent the current population after 5 years. So first of all, this A here is 25,000. R is our rate, which is in the calculator is going to be 0.032. Don't forget that 0. And then the T is 5 years. Okay, so here's our equation that we write out. Y equals 25,000 times the quantity of 1 plus 0.032 to the fifth. This is 1.032 to the fifth, and this to the fifth power, rounded to the thousandths. In this problem, you'll notice as I work through them, I keep changing what I round to, and I'll try to explain at the end. So then we have 25,000 times this gives me this. So the 25,000 with a growth of 3.2% yearly will end up with 29,275 residents. Okay, so now on number 2, it says calculate the population in number 1 for 10 years. So we're going to change the 5 to a 10. Everything else stays the same. So this to the 10th power is here, and we get 34,250 people after 10 years. Number 3 is 3 problems within 1. So let's take a look at it. Caden has $12,000 in his savings account. The bank pays 3.5% interest yearly. How much will he have after 3 years, 5 years, and 10 years? So the 3 years is here, the 5 years is here, and the 10 years is here. Okay, so our A is 12,000 for each of them. R is 0.035 for each of them. And then the 3, 5, and 10 changes. So our setup is 12,000 times 1 plus the rate to the power of 3. When I add those and take it to the third power, I get this. When I multiply, I get 13,308. So now 5 years, it's the same problem, only to the fifth power here, which changes this value, which gives me 14,256. And then 3, or the third part here, is to the 10th power, gives me this to that 10th power, which will give me 16. So the 12,000 calculated yearly, compounded yearly, that's a key thing, and you'll understand the difference here in a little bit. We get 13,308 for 3 years, 14,256 for 5, and 16,932 for 10. So now on number 4, we're going to do it a little bit more realistic, and that is, this is how the banks will actually calculate your interest, and it's compounded. They do it daily, okay? So let's take a look here so we get to understand how this works. So banks can calculate your interest quarterly, monthly, daily. To calculate compounded interest, the formula is given here. Notice instead of R, it's R divided by N, and instead of just T here, it's NT. Well, the N is how many times we're actually going to calculate it. So if it's quarterly, that's 4 times a year. Monthly, 12 times a year, and then daily is 365 times a year. So on your calculator now, things are going to get a little tricky with the decimal and decimal places and where you round. So our R, notice here A is 10,000, R is 0.1 because it's 10%, and then N is going to change depending on how we do it. So our first one we're going to do quarterly, so N will be 4. So 0.1 divided by 4, we get 0.025, and then it's NT, so it's 4 times T is 40. That means we're going to calculate this interest 40 times over these 10 years, which will give me a 2.685 when I do this number to the 40th. When I multiply, it's 26. So the $10,000 after 10 years will be $26,850. Notice the difference between this answer and how it more than doubled and the one up here. When we did to the 10th power, it didn't double because, again, we're not compounding it more. We're just doing this simple interest rate here. Down here on number 4, we are compounding it, which the difference is this. After the first quarter, when you calculate the second quarter, you're making money on the money you made first quarter. And then your third quarter, you're making money on top of the money you made first and second, including the extra you made off of the first quarter. And then the third, fourth quarter, so forth, it keeps growing that way. So over 10 years, your money is going to basically, you're going to get 2.5 times, or it's 2.6 here, 2 times. So your $10,000 will become $26,850. Okay? Well, now let's take a look here if we do it monthly. So now it's the same process. It's the 0.1 divided by N, which is 12 now. Notice it gives me a different decimal here. This actual number is a little smaller. But now it's going to be to the 120th because it's 12 months, 10 years. Now we're going to calculate it at 120. So you have 120 opportunities to make interest on your interest is really the way it works out. This to the 120th power, again, where do you round? Well, your answer down here changes drastically depending on how far you round out. So I keep rounding out a little further each time, okay? So here I now, instead of getting the 2.685, when I do it to 120th, I get 2.7. So when I multiply, I get $27,059, okay? Now, what about if I do it daily? Well, daily, I'm going to go 0.1 divided by 365. I get a really small number here, okay? But I'm also going to have 365 times 10, which is going to be 3,650 here, okay? And then when I do this number to 3,650, again, I get something now that's a lot closer here, okay? But how far do I go out for my rounding? Well, the more exact you want it, then the more decimal places you're going to have. Okay? So think of this now as you're fast forwarding to your next quiz. That includes this. Okay? Now you're going to have to, when you turn something into me, you're going to have to actually show me your work. Because I'm not just going to look at your answer. I got to see basically what are the two numbers you're multiplying, what are you rounding to, so I know how exact your answer is. So I know whether or not to, if it's correct or not, okay? But either way, notice we went from 26,850 to 27,59 to 27,181. These three aren't that big of a difference, but notice how big of a difference it is from now, granted, the numbers start with are different, but he started in problem 3, he started with 12,000, and then after 10 years only had 16,000. And here, when in number 4, when he started with 10,000, a smaller amount, but compounded your interest. So you're making money off of the money you made. Notice you ended up with a much larger value, even though you started with a smaller value. The point in these problems for 3 and 4 is that I want you to understand that compounding is huge. And it works against you as well when you do a loan. It's that same compounding happening when you do a loan. But we'll get to that in a different day. Not today. All right, so number 5, here we're just working through the problems very similar to the problem we just did in 3 and 4. So we have the problem, determine the total amount, 25,000 at 5%, and then these amounts. So we have 25,000, then 1 plus r divided by n, remember your formula, r divided by n. So here, when you're going to do the quiz, I'm not going to have you memorize the formula. You can use your notes to figure out what the formula is on the previous page. So we divide that out, and then it's going to be 12 times 4, because we're doing it monthly. Compounded monthly is 12 months in a year, and 4 years, so it'll be 12 times 4. This math right here is this, again, rounded to this place value, and then add these two numbers together, and take it to the 48th power. I do both of those to get to here, okay? And when I do that to the 48th, this is what I get, and then I multiply this times the 25,000, and I get 30,000. So 5%, 25,000, 5%, 4 years compounded is 30. One of the things I thought of here, and I'm sure many of you probably pointed out when you were looking at 3 and 4, one, it's 3.5% rate, and down here at number 4, it's 10% rate. So there is a big difference there. Anyways, so number 5 again is here, and then number 6. Determine the total amount, 100,000 at 8.5% for 12 years, and it's going to be compounded quarterly. That's 4 times a year. So this will be 0.05 divided by 4, and then we're going to add those numbers together, and then we're going to take it to the 48th power. And when you do it to the 48th power, notice we get 2.7, and then when we multiply, it'll be 274,000. So when your interest rate gets higher, notice how I got to 2.7% versus here when I had a small interest rate, I only got to 1.2. 1, the number of years and how you compound it, and 2, your interest rate has a huge effect on your answers. All right, so there we have it. Hopefully you don't have any questions on compounding your interest. You have those set up. Obviously you'll have some problems to do. Now, one other type of problem we want to work with works in the same kind of model as exponential decay. So for exponential decay, we're going to subtract the r. Okay? When we're doing growth, we add the r. Okay? Decay, we subtract. 1 minus r for decay and 1 plus r for growth. So number 7, my tractor costs $45,000 and will depreciate, decay, by 12% per year. So how much will it be worth after 5 years? So 1 minus the 12% is going to be 88. Okay, so after 1 year, it's basically your 45,000 is going to be 88% of the value. But then it keeps going after each year. So 45 times, and then the 0.88 to the 5th. Again, where do you round? It's up to you where you're going to round to. The more places, the better, the more accurate you are. So over those 5 years, the 45,000 depreciating or decaying at 12% per year, the tractor is now going to be $23,000. So it's pretty close to half after 5 years. Number 8, population of School City is decreasing by 5% per year. The population is 755,000 for 10 years. So we're going to have our formula from up here is 1 minus 0.05, that's 5%. When I subtract those, it's 95. But then to the 10th power, it is going to be 0.59. Again, I went way out this time. And when you multiply, you get 452.46. For the new population, obviously we're not going to have part of people, so I just terminated it there. And then I showed the problem with a different rounding to a different spot, and showing that we get a different answer. So it's very important that I see what you're rounding to and round correctly, because if you round wrong, obviously that's a mistake. And then down here, I just showed you some problems here, taking the same numbers to the exact same power, 1.01. This is a situation where it's 1%. Anyways, and to the 100th power each case, but I went out another decimal point, and notice the difference in the factor here changing. So what you round to, it does have an effect, okay, on your answer. So please be careful. No, I'm not going to tell you specifically what to round to. You should, as a general rule, if you have a 6-digit number, you should have a 6-digit decimal. Is kind of what you could use as your rule, although I'm giving a little flexibility. Okay? All right, that's rounding. Now, here are the 3 formulas. So if they're talking growth, it's the 1 plus r. Decay, it's the 1 minus r. And the compound growth, the way the real world usually factors, especially in the financial world, then it is the 1 plus r over n, and then the nt. All right, using your notes now, hopefully you can work through these 8 problems. So page 44, 1 through 8, and good luck.